Namaste to all of you. Today date is 27th date. In the last class, last example I given this one. I hope that this is clear for you. If you can't understand 2 or 3 times, you will listen the explanation part so that you can understand easily. Okay, I hope that this is clear. I will go to next example. Now, after this example, so total you can solve this exercise 1, try to solve it more. You can understand. Now, today one more thing I will explain. Okay, in this class, I will explain number of terms. Here the example is, and you can remember as one formula also this one. Okay, find the number of terms in a plus b plus c whole power n if they will give like this. In general, a plus b whole power n, if n is the positive integral index, already you know the number of terms is equal to n plus 1. That is the concept already we given, it's completed. For example, 3 variables are there here, a plus b plus c whole power n. Then how many terms will be there? Listen for this one. So here the expansion is a plus b plus c whole power n. If you expand this one by taking this is a, this is whole value as being c naught into a power n plus c1 into a power n minus 1 into b plus c plus c2 into a power n minus 2 into b plus c whole square plus c3 into a power n minus 3 into b plus c whole cube plus 1 plus cn into b plus c whole power n. You will get this one. Now, number of terms is equal to, my requirement is, my aim is to find number of terms only. Here how many terms are there? One term. Here if you simplify this value again, how many terms you will get? A power n minus 1 into b plus a power n minus 1 into c. Means how many terms you will get? 2 terms you will get. Plus, here b plus c whole square is there. B plus c whole square means, if you expand this value, what you will get? Tell me. How many terms will be there in b plus c whole square? 3 terms will be there now. So 3 terms into this value means 3 terms you will get. Plus, by proceeding like that, in the last, listen here, c naught 1 term, c1 2 terms you are getting, c2 3 terms you are getting. By proceeding that manner, cn is there now. So in this expansion, how many terms you will get? N plus 1 terms you will get. So already we know. What is the sigma n formula? N into n plus 1 by 2. One formula is there now. Sigma n is equal to formula n into n plus 1 by 2. So instead of n, here n plus 1 is there. What is the value? Sigma n plus 1 value nothing but n into n plus 1 by 2. Therefore, the number of terms in a plus b plus c whole power n is given by n plus 1 into n plus 2 by 2. This is the value. Okay, ma'am. Just keep in our mind this point. If three variables are there, if any positive integral index is given, the formula is this one, n plus 2 into n plus 1 by 2. I hope that this is clear for you. Next, one concept already I given in the last class. Middle term or middle terms. Okay, middle term and middle terms. How you can identify? Basing on the power value only. If the power value is even, there exists only one middle term. If the power is odd, you will get two middle terms. Like with one example I will explain. Here the example is find the middle term, find the middle term in the expansion of 3x by 7 minus 2y whole power 10, if they given like this. 3x by 7 minus 2y whole power 10. So that is the value they given. We have to find the middle term. Listen here. First of all, power 10 is there now. 3x by 7 minus 2y whole power 10. So in this expansion, in general, how many terms will be there? Since power is 10, so power is 10 means 11 terms will be there. So 11 terms means exactly middle term is given by t n by 2 plus 1. Means what is the value? T n value 10. So 10 by 2 means 5 plus 1. So is middle term is middle term. Then after finding sixth term is the middle term, you can identify T6 is equal to general term formula T5 plus 1. Then what is the formula? NCR A power n minus r b power r. This is the general term formula already you know. Instead of n, 10 is there. So 10c 5 into instead of a, 3x by 7 is there. So 3x by 7 whole power 10 minus 5 into b. What is b value? Minus 2y is there. Minus 2y whole power 5 is the value. Simplify, you will get the answer. So this is the middle term or middle terms basing on the n value. Here one example they given. If they given this value as 3x by 7 minus 2y whole power 11, if they will give like this, then within this case, how many middle terms exist? Middle term exist or middle terms exist? Since 11 is there now, so 11 means T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11, T12. 12 terms will be there. Out of these 12 terms, from the beginning, 5 you can delete. Last 5 you can delete. So these are the middle terms. So how you will get this value? T n plus 1 by 2 comma T n plus 3 by 2. So whenever if the power is odd integral value, whenever it is odd integral value, there you will get two middle terms. So these two middle terms are given by the formula T n plus 1 by 2 comma T n plus 3 by 2. I hope that regarding this middle term you understand. Okay. Next. Now in this class I will give one more important point. Greatest binomial coefficient. Greatest binomial coefficients. This is important. Greatest binomial coefficient. What is the greatest binomial coefficient? Simple logic. For example, 2x plus 6y whole power 5. In this expansion, what are the binomial coefficients? Binomial coefficients means power 5 is there now here. So directly the binomial coefficients are given by 5c0, 5c1, 5c2, 5c3, 5c4, 5c5. These are the binomial coefficients. So that is the reason, ma'am. Listen here. For example, T3, T2 plus 1 equal to what is, otherwise you may take TR plus 1. Leave it. TR plus 1 you can take it. What is the general term in this expansion? 5CR into 2x whole power 5 minus R, 6y whole power R. This is the general term. In this general term, listen ma, very very important point. Coefficient is different and binomial coefficient is different. Lot of difference is there. Coefficient is different, binomial coefficient is different. If they will ask in the general term, what is the coefficient? In this term, coefficient means you will get 5CR, 2 power 5 minus R, 6 power R. This whole value is named as the coefficient. Particularly, if they will mention binomial coefficient. What is the binomial coefficient value? Simply 5CR. That's it. So there is a lot of differences there between the coefficient and the binomial coefficient. Male, female difference is there. So don't confuse with this coefficient and binomial coefficient. Got my point, ma? So coefficient. Coefficient means here you have to consider 5CR into 2 power 5 minus R into 6 power R. Binomial coefficient. Binomial coefficient means this is only binomial coefficient 5CR. Got my point now? And now here what I given? Greatest binomial coefficient. Greatest binomial coefficients. So for example, if the power 5 is there, what are the binomial coefficients? You will get the binomial coefficients as 5C0, 5C1, 5C2, 5C3, 5C4, 5C5. And these two values will be equal. These two values will be equal. These two values will be equal. According to the formula, NCR is equal to NC N minus R. This is the formula already I given. So basing on this formula, NCR equal to NCN minus R, you will get these two coefficients are equal binomial coefficients. These two binomial coefficients equal, these two equal. Then if you calculate values, 5C0 value 1, 5C1 value 5, 5C2 value 10, 5C3 value 10, 5C4 value 5, 5C5 value 1. So these two are the greatest binomial coefficients. These two are named as the greatest binomial coefficients. Greatest binomial coefficients, like this. For example, if you take power 6, if you take power 6, what are the binomial coefficients? For example, a plus b whole power 6 they given. So power 6, what are the binomial coefficient? Tell me. 6C0, 6C1, 6C2, 6C3, 4, 5, 6. That's it. 6C0 value 1. So of course this value also equals to 1. 6C, 6 value also 1. Next, 6C1 value 6, and of course 6C5 value also 6. 6C2. What is 6C2 value? 6 factorial by means 6 minus 2, 4 factorial into 2 factorial. You will get the value 5 into 6 by 15 you will get. So 6C2 value, 6C4 value equal. This is also 15. Last 6C3. What is 6C3 value? 6 factorial by 3 factorial. 3 factorial means 4 into 5 into 6. 20 you will get. This is the value. So if the power value 6 is there, the binomial coefficients are given by 6C0, 6C1, 6C2, 6C3, 6C4, 6C5, 6C6. Out of these values, what is the greatest binomial coefficient, mom? 6C3 is the greatest binomial coefficient. So here I taken here one even integer value. Here I am taken one odd integer value. So with these two examples, we can conclude that what is the greatest binomial coefficient. So here if you observe, whenever if n is odd, here I am writing conclusion, listen. If n is odd, if n is odd, then there exists greatest binomial coefficients, since two exist and are given by nc n minus 1 by 2 comma nc n plus 1 by 2, like this one. 5c2, how you will get 5c2 value? 5c 5 minus 1 by 2. 5c3 means 5c n plus 1 by 2. So greatest binomial coefficient means among, listen mom, among nc naught comma nc1 comma nc2 comma nc3 comma so on ncn. First case, if n is odd, then there exist greatest binomial coefficients, two exist. What are those two values? Those two values are given by nc n minus 1 by 2 comma nc n plus 1 by 2. These are the values. Next, if the value is even, means if n is even, then what you will get? Then there exists greatest binomial coefficient, which is equal to nc n by 2. That's it. So this is the one more important point related to greatest binomial coefficient. And there is a lot of differences there between the coefficient and binomial coefficient. You have to observe that point also. There is a lot of differences there between the coefficient and binomial coefficient. Got it now? And the greatest binomial coefficient means here again two cases you will get. If n is odd, then there exists two greatest binomial coefficients. What are the two greatest binomial coefficients? nc n minus 1 by 2 comma nc n plus 1 by 2. For example, find the greatest binomial coefficient in the expansion x plus y whole power 7. So greatest binomial coefficient they are asking. Greatest binomial coefficient means power 7 is there. Na? So 7c 7 minus 1 by 2 comma 7c 7 plus 1 by 2 means what you will get? 7c3 7c4. These are the two values which are equal and these are the greatest binomial coefficients. Got it, ma'am? I hope that this is clear. Here one example they given. 1 plus x whole power 19. 1 plus x whole power 19. What is the greatest binomial coefficient? Since power 19 is there, na? Power 19 means odd. Odd means what you will get, ma? Greatest binomial coefficient you will get. Coefficients. Two coefficients you will get. What are the two coefficients? 19c, 19 minus 1 by 2 means 9. 19c, 10. These are the two greatest binomial coefficients. What are the formula? When n is odd, nc n minus 1 by 2 comma nc n plus 1 by 2. This is the values. I hope that this is clear. Okay, ma'am. After that, middle terms like that they given. Okay. Next, ma'am, in this, one more important concept is numerically greatest term. Numerically greatest term. I hope that this concept is clear for you. I will cut this one. Greatest binomial coefficient. Next, numerically greatest term. What is the meaning first of all? Numerically greatest term. First of all, what is that meaning? Numerically greatest term means what? For example, something they given like this. Find numerically greatest term when x is equal to 2 by 5. If they will give like this. Find numerically greatest term when x is equal to 2 by 5. In general, if you did expansion for this one, 1 plus x whole power 20, you can do expansion. If you will do expansion, what is the value? C0 plus C1 into x plus C2 into x square plus C3 into x cube plus up to so on plus C20 x power 20. Now, you can replace x equal to 2 by 5. Then what you will get? If x is equal to 2 by 5 means C0. Here what is the meaning of C0? C0 means 20 C0. That is important thing. Plus 20 C1 into 2 by 5 is the second term. 20 C2 2 by 5 whole square plus 1. Total how many terms are there? 21 terms you will get total. Now, in order to say that rth term is the numerically greatest term, to say that, listen here, to say that TR is NGT, then modulus of TR value is always greater than all other terms. This is the logic. Numerical value you have to compare. Sign you can leave it. Why I taken modulus means, here why I am taken modulus means simple logic here. There is no need of the sign. Even if you take minus also, here it is. Not an issue. So, this is the first term. This is the second term. This is the third term. Fourth term. 21st term. Out of all these 21st terms, in order to say that the rth term is the numerically greatest term, means this modulus of TR value is always greater than rest of all the terms, means you can compare with the first term, this is greatest. Then you can compare with the second term, this is also greatest. Like that, if you compare this rth term with each and every term, if it is absolute value is greatest, then we can say this is the numerically greatest term. Got it, ma'am? So, once again, numerically greatest term means, with one example I am explaining here. If I take the value 1 plus x whole power 20, then this expansion contains 21 terms. They will give when x equal to one particular value. Out of these 21 terms, in order to say that the rth term is the numerically greatest term, means if you compare modulus of TR value with any term, this is obviously greatest value. By substituting x is equal to 2 by 5. Then we can say the term rth term is the numerically greatest term. Now here the question. How we can identify? How we can identify? This particular term is the numerically greatest term. How you can identify? That is important. Na? In general, it is not possible to compare each and every term by giving x value 2 by 5. Is it possible, ma? For example, if we replace x is equal to 2 by 5, here 2 by 5, 2 by 5 square, 2 by 5 cube, 2 by 5 whole power 20. Can we compare each and every term? Can we write values more? 2 power 20 by 5 power 20 means very huge calculation you will get. So it is not possible. So directly without doing entire these calculations, one formula is there. One formula is there. With the help of that formula, directly we can say this particular term is the numerically greatest term among all the terms. Then directly we can identify that particular term. Okay. After getting the what is the term number. So here if you know R value, then we can say that is the numerically greatest term. Then how you can identify particularly rth term is the numerically greatest term? What is the formula we have to apply? Here one formula is there. The two in the expansion 1 plus x whole power n. This is important. The expansion should be in the form 1 plus x whole power n. To calculate numerically greatest term for NGT, numerically greatest term, we can calculate n plus 1 into mod x by mod x plus 1. You have to calculate this value. Okay, this is the important calculation. To identify NGT, numerically greatest term, in the expansion 1 plus x whole power n, we have to calculate n plus 1 into mod x by mod x plus 1. That's it. Of course, method is there, how it will come, but that not required. Simply our aim is to find numerically greatest term. How you can identify which term is the numerically greatest term is in the expansion 1 plus x whole power n. Okay, in the expansion 1 plus x whole power n, to find numerically greatest term, we calculate n plus 1 into mod x by mod x plus 1. This is the value. Now, if you calculate this value, let this is p. Imagine, let us assume this is the value p. Here again two cases. Maybe p is integral value or non-integral value. Two cases will be there now. Got it, ma? In general, listen all of you. To find numerically greatest term, first our aim is n plus 1 into mod x by mod x plus 1. Let this value you can consider as p. Then here again two cases. Maybe p value is integer. This is one case. Otherwise, p is not integer. Two cases will be there na. Either p is integral value or p is not integral value. Then how you can proceed? Listen, if p is integer, then NGT is given by TP comma TP plus 1. Remember this method. This is the point. If P directly integral value you can get, automatically TP comma TP plus 1. There exist two numerically greatest terms which are given by TP comma TP plus 1. For example, if P is not integer, then NGT is given by T step P plus 1. This is the value. For example, my P value some 2.3 you got it. P value 2.3, not integral value. In that case, step of 2.3. What is step of 2.3 value? 2. So T2 plus 1 means T3 term is the numerically greatest term, like this. So this is the one case and this is the one case. This is the first case, this is the one more, and this is the second case. Basing on this we can proceed. Just overall brief introduction I will give. Expansion should be in the form 1 plus x whole power n. In this expansion, in order to find numerically greatest term, first we can calculate n plus 1 into mod x by mod x plus 1. Then let this value assume as p. Then here two cases, maybe p value, integral value or non-integral value. If it is integral value, then in that case there exist two numerically greatest terms, that is given by tp comma tp plus 1. If p is not integral value, in that case the numerically greatest term is given by t step p plus 1. Means if p value some 3.2, then step of 3.2 means 3 plus 1, t4 is the numerically greatest term here. If directly p value some 5, you will get integral value. In that case two numerically greatest terms will be there, t5 comma t6, like that. Okay, basing on this one, examples in the next class we will do. Okay, thank you.